Hola clase! Today we are learning to model trigonometric functions, and for that we will work with the transformations of a function. As usual, I will give you a how to do it step-by-step guide, and then we'll make an example together. Transformations alter a specific trigonometric function and its graph without changing the overall trigonometric pattern, so the shape still looks like a sinusoid. This is useful because real cases can be modeled using trigonometric functions, and then I will be able to use them to actually find something about that model. Before starting, I need to know the overall shape of the sine and cosine graphs and how to identify a trigonometric function, which looks like f of x equals a times sine of b times x minus c plus d, or a cosine b times x minus c plus d, where a is representing the amplitude, b is the frequency, c will represent the horizontal translation, and d the vertical translation. For our how-to step-by-step, first start finding information about a and d. A will be the maximum minus the minimum over 2, and D will be the maximum plus the minimum minus 2. So A is half of the range, and D is the average between maximum and minimum. After that, the easiest one is to find B using information about when the maximum and minimum happen. Remember that B equals 2 pi over t, and t, one period, is one full rotation. The last one you find C, because that one depends on if you're using a sine or cosine. Remember, the cosine of alpha is the sine of alpha minus 2 pi. That same graph is being translated horizontally. Let's see this in an example. Here they tell me that the water level over the Wanganui River follows a sine curve, and I know when the depth is maximum and how much, and when it's a minimum. So I've got all the information I need to actually find a function that models that case. If I collect the numbers together in my head or in a corner of the paper, I know that the maximum is of 6.6 meters and it happens at 4:30. The minimum, 2.1 meters, happens at 10 o'clock. So I can do the first step and find A and D. A equals maximum minus minimum over 2. If I substitute, that will give me 2.25. And D is the maximum plus the minimum over 2, and if I substitute, that gives me 4.35. After having these two, using information about when the maximum and minimum happens, I can get B. I know that the maximum happens at 4:30, which is the same as 4.5 hours, and the minimum at 10. So there are 5.5 hours between them. That means that one full period will be twice as much, 11 hours. So I can get B equals 2 pi over the period, 2 pi over 11. And the last one, C, if I'm going to use a sine function, then I need to think that 1/4 of the period will be, in this case, 2.75 hours, and the maximum happens at 4.5 hours, which means the 0 that is immediately before that maximum will be at 1.75 hours. That 1.75 will be C, the horizontal translation, for a sine. If I'm going to use a cosine, then I need to think when the maximum happens, in this case at 4.5 hours. It should happen at 0, so all of that is the horizontal translation, the C. Once I've got all of these values, the last step is go to the function and substitute where they belong. So the function that models this specific case, f of x, equals 2.25 sine of 2 pi over 11 times x minus 1.75 plus 4.35, or which is equivalent to saying that the function equals 2.25 cosine of 2 pi over 11 times x minus 4.5 plus 4.35. And then I can use this function to find whichever value I need for this specific case of the water level of the river. And remember, these two functions are completely interchangeable. It doesn't matter which one you use later on. If we graph them, for example, using GeoGebra, and we graph the sine function first, which gives me this orange sinusoid, and then I graph the cosine function, we see that they overlap completely. They are representing the same set of points in a graph, as long as we are careful to use the correct horizontal translation, C, for each one. So after that, we can decide which one to use, and the results will be the same. Now it's your turn to go and practice. Thanks for watching.